I think I can make this out.
Yeah.
So where do we start here? Where's the vertical asymptote?
That's the bottom part equal to 0, so it'd be 2.
Yeah, x equal 2. So let's draw it in there. Okay. You're really going to do this to us? Is that numerator x squared minus 2x minus 3?
Yeah.
All right. Which factors into what? It's worth factoring it just to see if anything cancels.
Yeah. It'd be, let's see. X minus 1, x minus 2, or x plus 2.
First of all,
the
numbers have to multiply to 3.
Oh, right.
So the only factors of 3 are 1 and 3. And you put the larger factor with the sign of the middle term. So that's how the top factors. Since the bottom is that, I can't do anything. I cannot simplify that further.
Right.
If I could, that would create a hole. That's where you get holes. But you don't get a cancellation. So, what do we have to do? First of all, that's vertical asymptote, holes. What's that say? Well, X-intercepts, Y-intercepts.
X-intercepts, Y-intercept, horizontal axis.
Asymptote.
Yeah.
Okay. Well, this is a hard one because that doesn't have a horizontal asymptote. What kind of asymptote does that produce?
There's a vertical asymptote, but there's no horizontal asymptote.
But there is a slant asymptote.
Oblique. There's an oblique asymptote.
Oblique. In other words, you get an oblique asymptote whenever the degree of the numerator is 1 greater than the denominator. And we have we're only comparing that term to that term. In other words, it's only the highest degree of each that you compare. Since the numerator is exactly 1 more than the denominator, the step is to do the division.
Right.
X minus 2 divided into x squared minus 2x minus 3. Let's do this division, and the linear term we get will be the equation of the oblique asymptote.
Yeah.
Not sure we necessarily have to do it. I don't see any request for oblique asymptote, but that's what you got to do.
Yeah, I think. Yeah, she taught us about that, so I think she just forgot to put it.
So how do you put this? What's the first?
So you would put in x above the negative 2x.
Yeah.
And then multiply x.
The first thing you do is you take that and you divide it into that. That's always the first step.
Right.
Now you multiply that by both terms. Now you subtract, just like long division.
Yeah.
Then you bring down, that's the remainder. So it's x with a remainder of minus 3 over x minus 2. And I don't need to use the remainder sign. It's just that. That's the answer. I really don't care what that is.
Right. You just care about the x part.
That is the equation of the oblique asymptote. Y equals x. Well, y equals x looks like this. Okay. So now we have our basic grid laid out.
Right.
And that's whenever you have something that is hyperbolic in nature, which is to say you have a ratio of polynomials.
Right.
That's what it means to be hyperbolic. In other words, when you have a numerator that's a polynomial and a denominator that's a polynomial, their ratio produces hyperbolic functions. Now, let's see. There's no holes.
Yeah.
So we've got a vertical asymptote, x equal 2. We've got no holes. X-intercept. Well, we got to figure out how to graph this.
Right.
There's
So
no horizontal asymptote either. We have only a vertical and an oblique. Well, let's talk about this for a second. There's two possible ways this is going to look, and only two. One is like this, where your graph is in the first and third quadrants. Have you had trig?
Yeah.
So you know what I mean by first and third quadrant?
Yeah.
The other way is it's quite possible that it's in the second and fourth quadrants. It's either the blue or the red. Now, to answer the next question, we really need to figure out what the x-intercepts are. That will answer it.
Yeah.
Because notice the red has no x-intercepts. So if I find x-intercepts, it's definitely the blue.
Yep.
Now how do I figure out the x-intercepts?
You make y equal to 0.
Okay.
And so
I have 0 equals y squared minus 2x minus 3 over x minus 2. How do I solve that?
you cross multiply, so it's 0 over 1, so you multiply the x minus 2 by 0, and then the y squared minus 2x minus 3 by 1, and then you equal them both to 0, so the x-intercepts are going to be 3 and negative 1.
Correct. Basically, when you have a quotient that's equal to 0, the numerator has to be equal to 0. So I can pretty much ignore the denominator. You multiplied it, but 0 times anything is 0. So the net result is you always need the numerator to be equal to 0. And this factored into y minus 3 times y plus 1. So y equals, or excuse me, x equals 3 and negative 1. That's my blue line.
Mm-hmm.
So, but I don't even have, yeah, I guess they do want you to graph it, right?
Yeah, but she just said a rough sketch, so.
Okay, yeah, no, I understand.
Put a point in.
So if x is equal to 3 or minus 1, that definitely tells me it's the blue line.
Right.
Now, what's another way to figure out whether I have the red or the blue line? And this is worth knowing.
You can plug a number into, like you can take any one of the x numbers and plug it in for x.
Any number except 2.
Okay.
Let's
right,
pick a number to the right of 2. What number would that be?
3.
Okay, and if we plug it in, we get 3 squared minus 6 minus 3, all divided by 1. That's 9. That's 0. So when x is 3, right there, y needs to be 0. Well, it's definitely not the red.
Right.
It's the blue. I haven't drawn the blue perfectly right, so let's draw it right. It means the blue has to go through that. But it definitely tells us whether it's the red or the blue. So we don't necessarily need X-intercepts, although they help, because the X-intercept kind of told us the same thing. How do we get the Y-intercept?
The Y-intercept, you just take the end number, like the number for that in X, I forgot what they're called, and you make it into a fraction.
Hold on. Let's back up just a moment. You get X-intercepts by plugging in 0 for Y. You get Y-intercepts by plugging in 0 for X.
Yeah.
Very important concept. So plug in 0 for X, what do you get?
Everything goes away except for -3 and -2.
So you get positive 3/2.
3/2.
And we've answered all 5 questions, and we've graphed it, and I can erase the red.
Yeah.
It's not always easy to tell whether it's the red or the blue from the equation. It really isn't. I've never figured out a way to do it easily.
Yeah.
So I always allow for both of them, and then I figure out which one it is by picking a number on the x-axis and seeing where it should show up. Since it showed up at 0, it had to be the blue.
Right.
All right. Where's the vertical asymptote here?
The vertical asymptote would be 3.
Okay. It's actually x equal 3.
X equals 3, yeah.
In other words, a asymptote is a line. It's not a point.
Right.
So you have to define it as a line.
Yeah.
Where's the horizontal asymptote?
Is it 0?
It is. It's always 0 when the highest degree in the denominator is greater than the highest degree in the numerator. Well, the highest degree in the denominator is going to be x squared.
Mm-hmm.
There's only an x in the numerator. That automatically makes the horizontal asymptote y equals 0. So y equals 0. Now, you only get wholes from cancellations. If you have a factor in the numerator that equals a factor in the denominator and can be canceled, that produces a whole. That's it.
Right.
So none again, because I can't cancel anything.
Right.
X-intercepts.
Would it just be -1?
Uh-huh. So it's got to go through that point right there, which means it crosses the horizontal asymptote.
Right.
X-intercept is -1. It's where the numerator is equal to 0. What's the y-intercept?
-1/3.
Plug in x equals 0 and solve that.
Oh, is it?
Bottom is squared.
Right. -3, 0. Oh, it's 9.
It's -1/9. It's 1.
Oh, right. Oh, 1, yeah.
-3 squared. It's not -1/9, excuse me, it's 1/9.
Yeah.
So the y-intercept is 1/9. Now the only thing we have to do is graph it.
Yeah.
Do we know whether it's first and third or second and fourth?
We
don't really, and here's why. These two could look like this. First of all, it could be this. Remember, it has to go through that and then come back to the thing.
Right.
Or it could be like this, where the fourth quadrant, it's in there, and the second quadrant, it goes through that same point and then comes back at it.
Yeah.
So I have to go through the test of plugging in a number and figuring out whether I'm on the red or the blue. Now, that doesn't affect any of those answers, but it does affect the graph. And they do want you to graph them, I presume, since they gave you a XY grid over here. So tell me how to figure out whether it's the blue or the red.
So you'd have to use a number on the x-axis.
Okay, pick one.
Let's go -2.
It's easier to pick one as close to the vertical asymptote as you can get.
Okay.
And make it a positive one.
So, 4.
Okay, good. That's only one away from 3. It'll make the math really easy. So what does y equal when x is equal to 4?
You use the top one, right?
Well, hold on. We don't know which one we're using yet.
Okay.
We're just plugging in a value on the x-axis and seeing what y is. So the numerator is 5. X plus 1 is 5. What's the denominator?
5 minus 3 is 4.
No, our point was 4.
Oh, our point was 4, right. So it would be 1.
Okay. So y needs to be 5 when x is 4. Which graph am I looking at, the red or the blue?
Red.
Yes.
Right?
Yes, because it's really clear. And notice that by choosing a point close to the vertical asymptote, I really get a huge difference between the red and the blue. So if the blue would have been the answer, then this would have been like -5 or -8. In other words, there's never any question about what the curve is when you plug in a number, when you have hyperbolic functions. The moment you plug in an x value and you get a y value, you instantly know which curve it is. So let's erase the blue. And I still have a red curve that goes through the horizontal asymptote. That's okay. You can cross horizontal asymptotes. You just can't cross vertical asymptotes. So that's my graph. And once you cross a horizontal asymptote, you usually stay on the other side of it as you come back to the asymptote. The definition of asymptote is as x goes to -infinity, y approaches 0 or approaches the horizontal asymptote. So I know this thing goes through the curve because it has an x-intercept, and that's the only possible place that I can put an x-intercept. There's an x-intercept at -1. So I know the curve has to go through the point -1, 0, which means it has to cross that horizontal asymptote. And then it stays on the other side of it as it comes back and gets closer and closer to the horizontal asymptote. In other words, it doesn't do this. It doesn't go through it, come back on the other side and do that, because then I would have 2 x-intercepts, right?
Yeah.
So if there's only one x-intercept, you know it crosses it and stays on the other side. I've never actually seen one cross it twice. I've seen functions cross the horizontal asymptote once, but only once.
Yeah.
Okay. but this one. Vertical asymptote.
So 4.
Okay, no. 4 makes the numerator 0. It doesn't make the denominator 0. So,
what do you mean?
Well, you have to solve this equation. That's how you're going to figure out where the vertical asymptote is. Solve that.
Okay. -4.
Ah. -4 is what makes the denominator 0.
Right. I was using the numerator.
What's that?
I was using the numerator. I got this mixed up.
All right. What's the horizontal asymptote? I prefer they would ask that second. Hold on a second. Let's back up.
They have to factor.
Yeah, I didn't realize that we could factor it. And that changes actually the horizontal asymptote or the vertical asymptote also. In other words, what we really have here is x minus 4 over, if I factor out a minus 4, I'm left with x plus. So it doesn't cancel.
So it doesn't matter.
It doesn't cancel. I still do have a vertical asymptote at 4. I was so sure it was going to cancel.
Yeah, I know. It looked like it would.
Yeah, it did, didn't it? It sure did. But you got to be careful with those. They sometimes look like they do and they don't cancel. I think I did that right. That's minus 4x minus 16. Yeah. Okay. So we do now have definitely a vertical asymptote at x equal minus 4.
Yeah.
Now let's look at the horizontal asymptote. Next. There are no holes.
It would equal. Yeah, it would equal -1/4.
Yes. It's y. It's not. You have to say y because once again, this is a line.
Right.
I'm going to draw it as close as I can since there's just not 0, but it's not -1. It's a fourth, -1/4. Okay. As long as I've factored it, we'll leave it in that format there. If I set that equal to 0, where does that occur? To figure out the x-intercept.
4.
Okay, so if I go to the x-axis, I know that the curve goes through that point right there, above the horizontal asymptote.
Right.
Is there any other x-intercepts?
No.
Okay. And y-intercept is where?
It'd be 1/4.
Correct. Positive 1/4.
Yeah.
So I go through that point right there. So that kind of gives me enough to graph it.
Yeah.
I think. In other words, I think it has to look like this. There's no choices anymore. The only choice is whether it goes through that horizontal asymptote.
No, I don't think it will. I think it's,
Well, how can we figure that out?
Well, you just put like -5 in.
No. Here's the way you figure out whether it crosses the horizontal asymptote or not. In this function, we know where the horizontal asymptote is. It's y equal -1/4. So can that ever equal to -1/4? If it can equal -1/4, then it crosses that.
Oh, yeah.
So let's see if we can solve that. -1/4. Well, if I cross, or if I multiply both sides by the denominator, I get this. And let's see, that becomes x plus 4. Is that possible? No, if I cross the x's out, then I get minus 4 equals plus 4. That's impossible. X minus 4 cannot be equal to x plus 4. So that right away tells me that this function is never equal to minus 1/4, which means it never crosses that horizontal asymptote. Otherwise, it would be equal to negative 1/4 wherever it crossed it. And I can be 95% confident that I've got the right graph. And I've answered all their questions. And they're only looking for approximate graphs. But the key thing on these graphs is as to whether you cross the horizontal asymptote or not. And if you're in the right quadrants. We knew we were in quadrants 1 and 3 based on the X-intercept and the Y-intercept. That definitely put us in quadrant 1. And unless you have a strange function, it's always 1 and 3 and 2 and 4. Unless the bottom is an x squared greater than the top. In other words, if I have that, then that is actually graphed like this. In other words, I'm in quadrants 1 and 2. The reason is that the bottom is x squared. I don't even have an x in the top. So even if I had something like this, the bottom is an x squared greater than the top. That usually means you're going to have something that looks like that. Maybe on the other side, may look like this, but they both are in adjacent quadrants. They're not in opposite quadrants. I'm not sure you'll even get any problems like that. So it's probably safe to assume that you're in quadrants 1 and 3 or 2 and 4.
Right.
All right, what do we got? You got another something to send me?
Yeah, I sent you 4 pictures.
Oh, yes, you did. I forgot. And we started with the first one.
So it should be number 9. I don't know how in order they are.
Yeah, I can do 9 next. Now, sometimes that negative sign in front, ooh, this is exactly what I was just talking about. Notice the denominator is an x squared greater than the numerator. I would expect this graph to look something like this without any further work. I'm going to expect it to look not in first and second, but in third and fourth, like that.
Yeah.
And maybe even not quite like that. In other words, we've got to do some work first. And the work we have to do is figure out where all these things are. Like, where's the vertical asymptote?
So vertical asymptote would be
Solve that equation.
-3.
Solve that equation first.
All right, so you bring the 3x to the other side.
No, you don't. You factor out an x.
Oh, right.
And it makes a difference. If I bring the 3x to the other side, I lose the solution. Believe it or not, you do. You lose the solution. I'll show you here in a second. So now it looks like I got two vertical asymptotes. Where are they?
3 and 0.
Whereas, if I'd have done it the way you wanted to do it, I would have lost the 0 one. In other words, if I go back and I move the 3x over, I got x squared equal 3x. And then if I divide both sides by x, I get that. I lost my 0. And that's because if you divide an equation by a variable that can be 0, you lose that solution because you're dividing by 0. So the solution that x equals 0 completely disappears. And that's true all of the time. So that's why you don't ever really want to divide both sides of an equation by a variable if it's possible for that variable to be 0.
Right. And so the negative sign in front, that doesn't...
We'll get to that. Okay. No, at the moment is all we're trying to do is figure out our vertical asymptotes. And that's based entirely on the denominator being equal to 0. Okay, so I've got x equals 0 and x equal 3. That's my vertical asymptotes. Are there any? They put this question in here every time, and so far we have not seen a hole yet.
Yeah. No, there's
not going to be one here either. You only get holes when you can cancel a factor in the numerator and the denominator. And it turns what would have been a vertical asymptote into a hole. That's basically what happens. Okay? Are there any X-intercepts? Well, first of all, what's the horizontal asymptote? That really should be their second question every time.
0.
Because you got to lay out the grid to graph it at some point in time.
Right.
Now, are there any X-intercepts?
Would it be like 4 or -4, or are there none because there's no x on the top?
To get the X-intercept, I'm going to set f of x equal to 0, right? That's y.
Right.
Okay.
So
does that have a solution? What has to be equal to 0 if you have a quotient equal to 0? The numerator.
Right.
Well,
so 4 is
numerator is -4. So there is no X-intercepts. In other words, if you can't solve that equation, then there aren't any. And you can't solve that equation. That's impossible. There is no value of x that makes that thing equal to 0. Okay. About the y-intercept.
Yeah, I don't think there would be one.
Well, what do you do to figure out a y-intercept?
Because if you put x equal to 0,
exactly,
the bottom part cancels out, so it's just 4 divided by 0.
I want to make sure you knew that. That there's, in other words, the way you figure out y-intercepts is by putting 0 in for x. Just like the way you figure out x-intercepts by putting 0 in for y. Well, when I put 0 in for x, the denominator is 0. I can't divide by 0, so there are no y-intercepts either. I got my horizontal asymptote. I got everything I need. Now I just got to draw the graph. Now, let's first of all, here we got 6 quadrants, if you want to call them that. This one's, here, let me point with my mouse. This one's 1, 2, 3, 4, 5, 6. Okay?
Right.
So let me again hypothesize. Now, because the bottom is exactly an x squared above the top, I'm liable to have a strange looking graph here. In other words, well, first of all, let's figure out whether anything goes in quadrant 1. How do we do that?
So we'll just put in one of the x values.
Give me an x value to put in.
So, let's say...
Close to the asymptote.
4?
To the right of the asymptote. Yes, 4. So we get minus 4 over 4 squared, which is 16, minus 3 times 4, which is 12. That gives us minus 4 over 4 minus 1. So I know that when x is 4, y has to be minus 1. Well, that tells me quite a bit about this part.
Yeah.
In other words, I know it's not in quadrant 1. I know it's in quadrant 6.
Yeah.
Now let's check to the left of the left asymptote. The trick here is there's something that's going to funny happen in the middle. And then I still am not sure whether I'm in quadrant 3 or 4 to the left of the y-axis. So let's figure that out. Give me a number for x that's the left of the y-axis.
-1.
Okay. Now I got negative 4 over negative 1 squared is 1 minus a negative 3, which is the same as that. That's minus 1 also. So when x is negative 1, y is still. That's the kind of curve I was expecting, where they're on the same side of the x-axis. They're not on opposite sides of the x-axis.
Right.
That's all I got to do is figure out what's going on in the middle. Now, I know it doesn't cross the x-axis, right? There's no horizontal asymptote. I mean, there's no x-intercepts, so it does not cross the x-axis. There's no y-intercepts. So I basically got 2 choices. It can look like this. Oops. Or that middle part can look like this. Got to be one or the other. That's just the way the the other normal option would be it starts from the bottom and goes all the way through, but that would give it an x-intercept. So the fact that there's no x-intercept, I know it has to be either this red or the blue in the middle.
Right.
How can I figure out which one?
So you just put in 1.
Okay. So I get minus 4 over 1 minus 3. That is positive
2. Yeah.
Which curve is it?
So it's the red one.
Yes. And that, it would be very unusual to see the blue, because everything would be on the downside of the x-axis, and that's very unusual. I suppose one could come up with a function that did that, but this is a far more typical picture. And notice this follows kind of the rule. I don't know if I've talked to you about this rule or not. This rule is not ironclad, but it is definitely a rule of thumb. Start from the right. I'm coming upon this vertical asymptote from negative infinity, right?
Yeah.
So when I get on the other side of the asymptote, I need to be coming down from positive infinity. Just keep that in mind. As you cross asymptotes, the curve normally goes from one negative infinity or from one infinity to the opposite infinity. And notice the same thing happens as I approach the left vertical asymptote. The curve is on its way up to positive infinity, but on the other side of the asymptote, it comes up from negative infinity. So that is the most common pattern you see. In other words, once I know that that's what that looks like, I could almost bet dollars to donuts that this has to start on from positive infinity and do that. And then I also know that. So we've done that one. Okay. Thing is flashing. Oh, I get it. Okay. Vertical asymptote.
It would be factor out a -2 from the bottom.
That's actually, I was going to say that. As you were giving me an answer, I was going to say probably the best first step is always to factor. What's the rest of it?
X plus 3.
Okay. Now it's easier to tell where the vertical asymptote is.
So it'd be -3.
And that's it.
And that's it, yeah.
X equal -3. It's the only thing that makes the denominator 0. Horizontal asymptote is what they should ask next. What's the horizontal asymptote?
-1/2.
Ratio of the coefficients when the degree is the same. It's y equal -1/2. No holes, again, there's nothing that cancels. X-intercept.
-4.
Y-intercept.
-2/3.
Is that below the horizontal asymptote, on it, or above?
Below it. All right.
Yep. In other words, -2/3 is below -1/2. So that dot that I drew is not on the horizontal asymptote.
Yeah.
It's on our curve. And I still am not positive whether we cross the horizontal asymptote or not. In other words, at first glance, it looks like it has to be something like this. But a key thing is determining whether we ever, can this possibly be equal to the horizontal asymptote? We know we don't cross vertical asymptotes, but I know that is the horizontal asymptote. Oops, excuse me, that's 1/2. Put the wrong. You see why I set it to negative 1/2? Because if it's going to cross the horizontal asymptote, that has to be solvable.
Yeah.
Okay, well, I can multiply both sides by -2 to get rid of that, and to get rid of that, and to get rid of that. So now the equation that I have to solve is this. Can we solve that?
I don't think so.
No. You get x plus 4 equals x plus 3, which is impossible. 4 does not equal 3. So that tells me that our function never, ever crosses the horizontal asymptote. Well, if it doesn't cross the horizontal or the vertical, it's got to look like our picture.
Right.
Oh, I don't want to erase all of those, but okay. Once you get the hang of these, it becomes relatively straightforward.
Yeah.
As I say that, we come across this one. What should we do first here?
Factor.
Yeah, because we may be getting our first hole here.
Yeah, you do.
Factor the numerator.
X, and then in parentheses, x minus 3, x plus 3.
Okay, so it becomes x squared minus 9, which is x minus 3 times x plus 3. All divided by, and I'm going to take a guess here.
3x.
No, it's not going to factor. I don't think. 3x and x
plus 3.
Yeah, 3 works, doesn't it?
Yeah, so 3x plus 3, x minus 3.
Minus 3. Now I can factor 3 out of that. So I can do this. Oop. And that's going to turn into x plus 1. But I see an x minus 3 that'll cancel with an x minus 3. So let's do the holes first. They got these questions in the wrong order. You should always do holes first, vertical asymptotes second, horizontal asymptotes third, and then x-intercepts and y-intercepts. So let's do the hole first.
So it's 3. It's 3.
I'm going to say that there is a hole at 3. At x equal 3, there's going to be a hole.
Is it x equals 3 is a lot, just like a point?
It is. In other words, I'm going to graph the thing completely normally, and then I'm going to go to where x equals 3 and put a hole in the graph. Okay. Where is the vertical asymptote?
So vertical asymptote would be at -1.
Mm-hmm. What other kind of asymptotes do we have here?
Your horizontal asymptote would be wouldn't it be?
Notice the degree of the numerator is greater than the degree of the denominator.
Right.
I got to do the.
So you wouldn't have a horizontal asymptote, but you'd have to do division.
We're going to have an oblique asymptote.
Yeah.
Well, they don't ask for it, but we still need to graph it. So to figure out what the oblique asymptote is, the easiest way, rather than dividing this quadratic into that cubic, let's divide the new equation. In other words, we're going to divide 3x plus 3 into x squared plus 3x. Right?
Mm-hmm.
Do that division.
So you need to put an x above the 3x.
I'm dividing 3x into x squared is what I'm doing. It's always the first step when you're doing long division is you take only that and you divide it into only that.
Right.
So what do I get? I get 1/3 x.
Mm-hmm.
Now I multiply my 1/3 x by both terms. That gives me my x squared plus x. Subtract, I get 2x. No remainder. Now I divide 3x into 2x and I get 2/3. Multiply the 2/3 by the 3x and I get 2x plus 2. So I have a remainder of minus 2. So it's minus 2 over 3x plus 3. Don't care about the remainder. It's not even important. What is important is that is the equation of the oblique asymptote. Whatever the linear term minus or eliminating the remainder is the equation of the oblique asymptote. So how do I graph that oblique asymptote?
So you would just graph it like a normal line?
Yeah, so I go to the y-intercept at 2/3, and I have a slope of 1/3, which is up 1 and to the right 3. So my oblique asymptote looks like that. Hold on. My doggies thought it was time that I was done. Come on, Sonny, out. Bye. All right. So let me erase most of this. Now you can also cross oblique asymptotes. Although at this point, well, I'm going to have to draw the graph at some point. Let's look at our intercepts now. In other words, before I draw any graph at all, I want to see what my intercepts are. What makes the numerator 0?
So it'd be
What makes that
0 and -3.
Okay, so those are my x-intercepts. I know I got to cross, the curve's got to go through that point, and it's got to go through 1, 2, 3, this point. Boy, they're giving us functions that are so tight with this grid. They could have given us a bigger grid. Would have made it a little easier.
Yeah.
But I do know that I go through the x-axis at those 2 points. So it's it's 0 and -3 are the x-intercepts. How about the y-intercept?
Would it just be 0?
In other words, when I substitute 0 for x, the numerator is 0. That's my y-intercept. That's 0.
Right.
So it's that same point as my x-intercept. So that's pretty good. I'm pretty certain that my curve has to look like this because I know which side it is on.
Yeah.
And it's got to go through those points. Certainly don't look like very nice hyperbolas, but that's simply because they've given us such a tight grid that I can't put a proper looking hyperbola in there.
Yeah.
Now, question is, do we cross that oblique asymptote? Gosh, I'm not sure
I don't think so.
I figure it out, because that could come at any number of points. In other words, we might cross it there, we might cross it up there, we might cross it somewhere over there. So how do I know whether I cross it or not?
I mean, you can put a point in.
Well, that won't tell me. All that'll tell me is which side of the asymptote I'm on. But the only way to really know whether you're going to cross that asymptote, I'm not sure. I'm not sure I know how to do it. And
I think, I mean,
I'm not sure
it's just the
knows how to do it either. To be honest, crossing an oblique asymptote is not an easy thing to figure out without drawing. I'm sure they don't want you to use your calculator and graph that, right?
No.
However, just for the heck of it, let's do it on my calculator. Wolfram alpha. Just let's see whether we can tell whether it crosses that asymptote or not. What are we looking at? X cubed minus 9x divided by what? What's our...
That one. It's the first option, I think.
3x squared minus 6x minus... How did it know that?
Someone's probably put it in.
Are you kidding? I'm wondering, maybe I had another student that I did this with. Because how did it get that as a default? They didn't know what I was going to put in.
I mean, maybe the, like, someone who's doing this homework has put it in.
Well, it was me. In other words, I must have put it in at an earlier time, which means somebody else must have given me this exact function. And I just didn't remember it. And what reminded me was that it showed up in my default. And yeah, I mean, I can see the vertical asymptote and I can see the oblique asymptote. I can't really tell if it crosses the oblique asymptote. Doesn't look like it does, although I'm not sure that that would be visible. They don't put the oblique asymptote in here. So... Oh, notice also, I did leave one thing out of that drawing, and that was the hole.
Yeah.
Yeah, let me recreate it real quick here. Let's see, our horizontal asymptotes were where?
I can just put it in.
Asymptotes were where?
It was at -1.
Okay. And the oblique asymptote was?
It was 1/3 x plus 2/3.
Yeah, so it went through like that, had a flat slope like that.
Yeah.
And the curve we figured out had to be on second and fourth.
2 and 4, yeah.
So it was something like this. And the hole was at 3, x = 3, is that correct?
Yeah.
So I go to x = 3 and I draw a hole wherever the graph is. And that's how I show it. Okay? Now, the reason it did not show up on Wolfram alpha is because the hole is infinitesimally small. It is only at 3. And which means that it's so small that Wolfram alpha can't put it in there. But if you understand how holes work, you can do it manually. In other words, you can draw the hole. Why does this keep disappearing on me? Oh, I know why, because I X'd it out. So that's how you handle a hole. You have to draw it in, and you won't see it on your calculator, and you won't see it on any online calculator. Because it's so tiny, you wouldn't see it. In other words, it's only going to measure a micro inch in diameter, right? It's a single point. So a single point doesn't have a whole lot of width to it on a number line. So that's why the holes don't show up on your calculator or this program like Wolfram Alpha. But you have to put it in manually. All right.
Yeah.
Hayden?
Okay.
I've taken you over time. I apologize. I didn't realize I was 5 minutes over. Have a good day, and I will talk to you next time.
All right. Thank you.
Bye-bye.